Thank you. Can everybody hear me? So I am between Emily, who had some of the most phenomenal graphics I've seen in a good presentation. Mine has no graphics at all. Once they picked it up, it is very mundane. And lunch. I don't know how good the lunch is going to be, but I will have. I'll be on time. I'll finish on time. So thank you for taking the time out of your schedule and coming and attending my session. While I'm waiting for the slides to come up, let me give a little bit of introduction. My name is Sanjeev Sharma. I'm a Senior Vice President of Development and Engineering Platforms at Dell. We support all the hardware and software engineers at Dell who build all the fantastic products, whether it's a laptop or a monitor to a high-end server with 8 H200 GPUs to some the phenomenal storage products which Dell had for high-performance computing, AI, and general storage. So a wide variety of products which come out of Dell. My team supports all the engineers and developers who build, test, and release those products. It's a global team. We like to say we are spread out from Taipei to Tahoe. And we handle all the needs for software and hardware development. What I'm going to talk about is actually not something I do at work. It is something which I see happen with our clients, which I'm observing what our clients are doing. We are also doing it within Dell itself for our own data center and AI needs. But what I'm talking about is mostly what we are seeing happen in the world around us, mostly with our customers. And how many of you run a data center or have designed a data center ever? Right, one hand, all right. Then you have probably never heard this phrase, ping, power, and pipe before. But I don't know if you have, but as data center designers, when we would go out and design a data center, the first question we would try to get answered, the first set of questions we would try to get answered by the customer who wanted to use that data center was, what are your ping, power, and pipe needs? And I'll talk about what they mean. The reason I put this talk together and the reason I wanted to talk to you all today is because the definitions of those have changed as you have gone from a CPU, a traditional compute, CPU-based compute storage and network data center. If you look at a data center, that's all it is. If you walk inside a data center, all you see is rows and rows and rows of servers and storage and network equipment providing you compute power, place to store your data, and network that allows all these compute nodes and storage nodes to talk to each other and obviously talk to the outside world, connect the data center to the outside world. What we'll talk about today in the next 15 minutes or so is how is that changing for the AI world and how is that changing where you put your data centers? Because that problem arises when you're moving from training to inference. So let's jump in. I already, the clicker isn't working. Is this the right clicker? Doesn't go in any direction. It's not a Dell, definitely not a Dell clicker. Has to be powered on. Thank you. User error. I already talked a little bit about myself. As I said, I've been Dell at 2 years. Before that, I was at Truist Financial and worked for technology companies for many more years than I like to talk about. So let's talk about why this change has come about, right? Why is there sudden interest in AI? And I think I'm in the middle of day 2 of this conference. I'm sure others have talked about this, but there are 3 vectors which have kind of changed the industry. The first is the evolution of GPUs. We've gone from the GPU power has gone up so tremendously from what it was a decade ago to what it is today, that today you buy the GPU and then you figure out what server you're going to put it in, right? I had till recently never bought a computer because of its GPU. I'm not a gamer, right? But other than gamers, nobody bought computers because of their GPUs. They bought a computer, and every computer you guys have owned in your life had some kind of a GPU or video card in it. But today, because of the compute power of GPUs has so far exceeded that of a CPU, that you're actually buying the GPU and then figuring out what server to put it in. The second thing which happened back in 2017 was the transformer paper. Came out from Google, which the paper is called Attention is All You Need. And it talked about the whole concept of a transformer, which is the basic technology on which LLMs are based. So if you haven't read this paper, go ahead and read it if you like to nerd out. If you don't like to nerd out, there are more than ample podcasts and videos on YouTube which explain this paper to talk about how a transformer does matrix multiplication to allow it to learn and then answer questions based on a large language model. And to do that computation, you need a GPU. The third thing which happened, which really all of us noticed, was OpenAI came out. And what OpenAI did with ChatGPT was democratize the access of AI. Till then, AI and machine learning, I mean, I wrote AI code back in 1990, when I was at George Washington University doing my PhD, and we were writing genetic networks, and neural networks, right? And we were using papers which were written in the 60s and the 70s, which talked about what a neural network is. It's not new. What's new is with OpenAI, you got a Google-like prompt, and you could ask it anything if you knew the English language. And now there are other languages available. I saw some vendors outside who have non-English language, chatbots, and it's not democratized. Anybody can go to a prompt which looks not very different from a Google prompt and ask it anything. Today, when I'm trying to research anything, I don't go to Google. I go to Prexpelity usually, or ChatGPT. In my case, I love Prexpelity because it gives all the sources, and I ask it whatever the heck I want. Or the latest one is Notebook LM. I don't know if you use Notebook LM from Google. You can upload the ChatGPT, the transformer paper to it, and it'll create a podcast of two people talking, explaining the paper to you. It's incredible. And it sounds human. They are not like AI-generated voices. But in reality, there are two markets. And all the hype you see today about people buying thousands of GPUs and spending billions of dollars of GPUs, Elon Musk, for his XAI, purchased 100,000 H100 GPUs and put them in a warehouse in Memphis, Tennessee. And he's using every tweet we've ever written on Twitter, what was previously known as Twitter, to train it. And it'll be able to answer anything anybody has ever discussed in Twitter, which is pretty much the entire human experience. That's 100,000 GPUs, and he has got two other factories like this he's building with AI GPUs in it. But what that's being used for is training, to train the model. The second market is inference model. Okay, I have a model. I have trained my model on biology. I've trained my model on my catalog of offerings. I've trained my model on I'm a hospital, and I've trained my model on what a doctor ought to know. I have an agent. I was talking to somebody earlier on who uses an assistive agent, a co-pilot for an agent in a call center. I've trained that agent. Where do I now run the model? In the inference side, where I'm running the model and trying to get answers out of it, latency becomes a problem. Power becomes a problem. The throughput becomes a problem. Ping, power, and pipe. Because for latency, I want the answer immediately. If I'm doing pure text like ChatGPT, it really doesn't matter whether I'm in Antarctica talking to a server in Ashburn, Virginia, where most of Amazon, AWS, Azure, everybody has a data center in Ashburn. Because it doesn't matter, text is pretty fast, yeah, but it is a distance, speed of light problems and all that. But if I'm talking about multimodal AI, where it is a voice bot that I'm talking to, or worse, video, where it is a two-dimensional continuous video, latency becomes a major problem. Let's talk about a case study. Here is a case study of a retailer. I won't tell you who. This was a luxury goods retailer, which obviously customer service is primary for somebody who sells luxury goods. And they built a video chatbot, hired a company to build them a video chatbot of their CEO. And he had an avatar which was running on a massive screen. The moment you walked into the store, if a salesperson was not available to greet you, that video chatbot greeted you and asked you what you wanted. Worked great in the POC. But when they went to a store in North Carolina and deployed that video chatbot, the video chatbot became very laggy. You would ask it a question, the poor avatar would, like a normal AI buddy, bob up and down like that, and 5 seconds later respond to you. Because what? It was talking all the way back to the servers running the AI, the inference engine on Azure in Ashburn, Virginia, and US East 1. Then it'll process it and then send the signal back to the North Carolina, and then it would process it locally and then render the video. That latency was not acceptable, and the whole project failed after they had spent millions of dollars to train the chatbot. The answer, the solution which was given by the vendor was, let's put a node, a compute node, a GPU, right here in your store. Now that involved putting GPUs there, that involved getting power into the store, that involved cooling the GPUs. These GPUs are very, very heat up real fast, so you need to spend a lot of power and energy to actually cool them. It's not like your laptop where it's just the fan running and you need more than that. In most cases, these are liquid cooled, which means you can't just put that computer anywhere. In many cases, if there are many GPUs, you'll need a source of cold water which rotates through it, and then you need a heat exchange outside the computers where the hot water gets cooled down and your heat is released. This was not going to work. This was too expensive. The cost of maintaining it was too high. You would need an expert to fix it if it broke. So this whole project became problematic because of the latency requirements and the power and cooling requirements. What was the fault here? The fault was that the company which was building the solution never looked at the ping, power, and pipe requirements of the solution they were deploying. Ping is latency, right? Our marketing department hates it, but I always try to sneak some meme into one of my presentations, and they didn't get to removing this one. And by the way, if you know what this one ping only meme is, you and I can be friends. If you don't know what it is, go watch a movie called The Hunt for Red October, and you will know what I'm talking about. Ping is network latency. It is how much time does the round trip take to talk to the server and come back, right? Today, the furthest distance we can do a ping to is the Voyager 1 spacecraft. The ping's one way is 23 hours because it's the furthest man-made object which we can talk to in human civilization. The problem with the ping, and most people, by the way, confuse ping with bandwidth. I actually had a heated discussion with the CIO of a bank who said, no, they told me I can buy more bandwidth, it will go faster. I'm like, no, it cannot go faster than the speed of light. Einstein prohibited. Right? That was only way I could end the conversation because there are limitations. The electrons can only travel as fast as the speed of light until we solve the quantum issue where we can get real-time interaction between two distant objects. In today's non-quantum world, it is the speed of light, which means if you have your end node in North Carolina and your compute is running in Ashburn, Virginia, or worse, somewhere on the West Coast, you have the speed of light as the limitation, which is the latency of your network. It doesn't matter how much bandwidth you buy. In fact, the worst commercial I have seen in this space is the 5G commercial. I won't tell you which company made it, but they say, oh, there's a surgeon in New York doing surgery on a patient in London. That's not how it works. Yes, I can get extreme bandwidth to be able to see the patient and get full 3D video of the patient's innards which the surgeon is handling, but the latency of the network between New York and London does not get solved by 5G or 6G or 10G. It's limited by the speed of light. The second issue, as I've already alluded to when it comes to putting servers to run inference, is power. I need power to run the GPUs. I need power to cool the GPUs. That power has to be cost effective. In Virginia, if you have a commercial unit, you're going to pay 8 cents per kilowatt hour. If you go up to the northeastern United States, it suddenly jumps up to 37 cents kilowatt hour. So the cost of putting an edge node in North Carolina versus the cost of putting an edge node in Boston, Massachusetts is very different. The other question which I didn't know, I couldn't find a P letter which works with it. These GPUs are heavy. If you have a rack with 32 GPUs on it, in most buildings you cannot put it on the second floor. The floors cannot handle the weight. You have to put it on the ground floor. I am currently in the process of moving one of my labs from the second floor of a building to the ground floor of a building because we want to put several racks, all of which have 32 GPUs in them, the new B200 types, which B100, B series GPUs, which are extremely heavy. And the weight of the floor cannot handle the weight. I don't know, if somebody thinks of a word which starts with P, which represents weight, let me know, I'll add it to the ping, power, and pipe discussion. People neglect the power of cooling. you need power to cool something. You need cold air or you need water in order to cool it, and takes up power too. Or you need to run you need to put it in a place which is really, really, really cold, which limits most places now, especially with climate change. We might have fewer places which are really cold. I don't know if you saw this in the Bitcoin mining days when Bitcoin mining gave you a very good return. They were putting these Bitcoin mining rigs in open air data centers in the middle of mountains where the cold air would cool them, right? Well, you can't put a real data center there, but for Bitcoin mining, it worked perfectly fine. Pipe is essentially the throughput. In a traditional data center, when we talk about pipe, we talk about the bandwidth of how much megabytes per second or gigabytes per second can go in and out of the data center. But when you talk about pipe in the terms of AI, you're talking about token rate. When an AI does inference, essentially what it's doing is an LLM works is it is trying to guess the next token. In the text world, a token is 2 tokens make up 1 alphabet character. In the graphics world, it is 1 pixel on your screen, right? That's all it's guessing. So based on the GPU you have, based on the memory you have, you're going to get a certain token rate. And there are tools available in the market. The screenshots I have are from an open source tool called GPU Poor, where you can tell it what model you're using, tell it what chip you have, GPU you have, and it'll tell you what your token rate will be. And you'll be surprised. In fact, I compared a A6000, which is a data center chip, with the RTX 4090, which is a commercial video card. And the RTX 4090 actually gives you a better throughput on a Llama 7B model. So that throughput, that pipe, is very important to understand, because if you want your video to go like this, not to go like that rather, you need a very high bandwidth of tokens. That has nothing to do, it has something to do with your network, but more to do with your GPU and how much memory you have. So the types of GPUs, how much memory that GPU has, how much storage you have, how fast is the storage, is very important. How do you figure that out? You got to do a true value stream mapping of what happens from the point a customer or a user enters a prompt, whether it is voice, video, or audio, or text prompt. How does that data flow to the server where your inference engine is running? What does the inference engine do? How many lookups does it do? Are all the lookups local? Is it going to talk to OpenAI or some other API? How much storage does it need to access? Is it going to go do a search because it thinks you are an existing customer? Is it going to search through 100,000 customers you have, do a query on it to find you? Is it going to do some authentication with a third-party system? And then do the inference, do the computation, do the inference, and release a certain number of tokens at a certain rate, which are now going to flow back over the network, back to your end unit, your computer or the interface where your customer is actually interacting with the AI. That data flow has to be value stream mapped so you can figure out where are my bottlenecks. Is it with the GPU? Is it with the memory? Is it with the network, due to latency? Is it because of the bandwidth of the network? Is it because of my storage is not fast enough and I'm using regular spinning disks rather than flash disks? Or I just don't have a powerful enough GPU for the amount of computation I'm trying to do, so I'm not getting the token rate. Till we understand that, you won't know what the exact pipe or what the throughput of your per token throughput of your AI model is going to be. So all these, to wrap up, lead you to ask the question, lead me to ask you the question, or you to ask yourselves the question, are you AI ready? The hype around AI is there. Everybody wants to do AI. But what model are you going to use? Where are you going to deploy it? Are you training your own foundational model? Or are you taking a foundational model and fine-tuning it? How big is the model? Is it a 7 billion parameter model? Is it a 23 billion parameter model? You cannot run a 23 parameter model on a CPU running at your edge node. You'll need a GPU or a cluster of GPUs. Once you fine-tuned your model, how do you continue keeping it fine-tuned? Do you need to take an input which every interaction which happened with a user, learn from it to reinforce and fine-tune your model further, or is it fully baked? Where are you deploying that inference? Is it in the cloud, in which case latency becomes a problem? The ping, power, and pipe, you cannot control then, because the cloud provider is controlling it, right? And you are going to be limited by how far is the cloud provider, which which data center are you using? What are the user experience requirements of your AI model? If your AI model can work in an intermittent asynchronous form, that's fine. But if you need real-time video level or audio level interactions, the user experience is going to be very different based on what your token return count is. How are you calculating the AI ROI of your AI model? If it's going to cost you $1 million per store, like it was going to do for that case study I gave you, and they, in order to put that video chatbot in every store, the ROI was definitely not going to be there. That video chatbot was not going to earn them $1,001,001 every year. And these GPUs also don't have a very long lifetime. You should assume you'll need to replace them in 3 years. Finally, given those cost constraints, how do you figure out what the ping power and pipe are, and what do you need to change? Do you need to invest in improving the ping power and pipe, or do you need to change the model you're using? All these considerations will need to go into you figuring out how to deploy AI in production. All the hype about training is great, but eventually we got to deploy them in production, and they need to give us the ROI that are needed. My clock's at 0. Thank you very much. I'll be around if anybody has any questions, and enjoy lunch and in the rest of the conference.
Thank you so much, Sanjeev from Dell. Let's give it up for him one more time.